So let's solve a problem on, just a simple problem on an RC series circuit. So here we have problem in RC series circuit. Now, so let's say we have this example. Find the impedance. Find the impedance and the capacitive reactance. No, sorry, and the current. Flowing in the circuit below. So here we have your V, here we have a 3 ohms, here we have 2 microfarad. Now what the ammeter will be reading, we don't know. And here's the AC source. The voltage of the AC source is around 250 volts, and the frequency is, let's say, 50 hertz. So now we are supposed to find the impedance in this circuit and also the current flowing through it. So we have solution. Now the first thing you should do is to write out all the quantities given to you. What are the quantities we have? Resistance was given to us, and it's 3 ohms. Capacitance was also given as well. 2 microfarad, which is the same thing as 2 times 10 to the power of minus 6 farad. We have what else? We have the source, the voltage, the potential difference of the source, and it's 250 volts. We have the frequency, and that's 50 hertz. You see? What else was given to us again? Okay, that's what we have. Now we've been asked to find number 1, the impedance. Now, from the video we did earlier, you could see that the impedance in an RC series circuit is Z, and is equal to the square root of the square of the resistance plus the square of the capacitive reactance. Now, we already have our resistance here, but there is no capacitive reactance, so there is no way we can find the impedance. The first thing we should do is to find the capacitive reactance. So we say, but the capacitive reactance is equal to 1 over 2 pi Fc. Of course, we can, so that implies that the capacitive reactance is 1 over 2 pi, what is F? F is 50. Multiplied by 50, multiplied by what is C? 2 microfarad, which is 2 times 10 to the power of minus 6 farad. Now, the whole of that is equal to, now this one will have to go up, 10 to the power of minus 6 will go up, and once it goes up, it becomes 10 to the power of plus 6 all over 2 pi 50 multiplied by 2. Now 2 times 2 gives us 4, right? So we have 4 pi. 4 times 50 gives us 200, and that implies that capacitive reactance is equal to 10 to the power of 6 divided by 200 pi. You see? Now these two will take 2 zeros from here, making 10 to the power of 4. Now 2 divided by 10,000 gives us 5,000. So we have 5,000 over pi ohms. So that's the value of our capacitive reactance. Now we can now put this value into this place to find our impedance. So the impedance is equal to the square root of what is R? R is 3 squared plus the capacitive reactance is 5,000 all over pi squared. You see, which will give us the square root of 9 plus, because 3 squared is 9 plus, now I'm not carrying a calculator here, so I'm just going to leave this at this. Then we put ohms, since that's the unit of impedance. You see, so if you have your calculator beside you, you can do this to find the numerical value of a more simple value for the impedance. So now the next question is find the current. Now current in this case is equal to V all over Z, coming from Ohm's law, and this comes from Ohm's law. Now what is V? Which V is what? The potential difference of the source, and that means we have I is equal to 250 divided by Z. What is Z? Z is the whole of this, which is 9 plus 5,000 all over pi squared ampere. Again, if you have your calculator with you, you should be able to find a simpler value for the current. So this is the answer.